Introduction to Chemical Analysis. What is analytical chemistry? Analytical chemistry is science of chemical measurement, provides the methods and tools needed to gain insight into our material world. It helps scientists understand materials by answering four fundamental questions. First, what? This identifies the substance in question. Second, where? This investigates the origin of the substance or where it came from. Third, how much? This quantifies how much of the substance is present in the sample. And lastly, what arrangement? This explores the structure or form of the substance. We'll walk through the key steps involved in their important work for chemical analysis. First step is sampling. Take a small sample, reduce it by grinding or drying to prepare it for testing. Then comes sample preparation. They prepare the samples in the lab. Next, chemical analysis, determining the physical properties and chemical composition of matter. Calibration curve to determine the unknown concentration of a substance in sample analyte. Finally, analyzing the results, evaluating data from experiments, meaningful conclusions of sample properties. Let's explore how we choose the right analytical technique in chemistry. First, we decide whether we need qualitative or quantitative analysis. Qualitative analysis tells us what's in the sample. It identifies the analyte, what chemical is present. It includes tests like color change, flame test, or rapid test kits, where the focus is just on identity, not amount. Quantitative analysis, on the other hand, tells us how much of a substance is present. This involves measuring concentration, using precise instruments, and analyzing signals. Accuracy often depends on the tools used and the chemical principles behind them. Once we choose quantitative analysis, there are two main branches: classical and instrumental analysis. Classical methods include gravimetric, which measures mass, and volumetric, which uses titration to find volume. Instrumental methods are more modern. These include electrochemical, using electrical signals; spectrochemical, using light or color; and chromatographic, for separating substances in mixtures. Now let's move on to calculation of molar concentration. Three fundamental concepts in solution chemistry: molarity, molality, and normality, each representing a different way of expressing the concentration of a solution. We begin with molarity, one of the most commonly used concentration units in chemistry. The formula to calculate molarity is molarity equals moles of solute divided by liters of solution. Alternatively, for smaller quantities, it can also be expressed as millimoles of solute divided by milliliters of solution. Next, we have molality, which differs from molarity by focusing solely on the mass of the solvent, rather than the total volume of the solution. Its formula is molality, m, equals moles of solute divided by kilograms of solvent. It may also be represented using smaller units, millimoles of solute divided by grams of solvent. Finally, we consider normality, a concentration unit that takes into account the chemical reactivity of the solute. Normality measures the number of gram equivalents of solute per liter of solution. The formula is normality, N, equals grams of solute divided by equivalent weight times liters of solution. Let's now talk about percent composition. Weight to weight percent, used when both the solute and the mixture are measured by mass. The formula is mass of solute divided by mass of solution or mixture, times 100. This is commonly used in solid or semi-solid mixtures like creams or powders. 2. Volume to volume percent. This is used when both the solute and the solution are liquids, measured by volume. The formula is volume of solute divided by volume of solution, times 100. A good example is alcohol in beverages. 3. Weight to volume percent. This is typically used in solutions where the solute is solid and the solvent is liquid. The formula is mass of solute divided by volume of solution, times 100. This format is common in medical and laboratory settings, such as saline solutions. Percent composition also tells us how much of a substance is present in a solution, often at very low concentrations. We use units like parts per thousand, million, billion, or even trillion. These are written as ppt, ppm, ppb, and ppt, and expressed as weight to volume ratios, such as grams per liter or micrograms per kilogram. Let's learn how to prepare solutions accurately and safely in the lab. Preparing a solution involves a few important steps. Firstly, know your reagent and solvent. Secondly, know the molarity and volume that you need. Thirdly, start calculating. Get the weight of reagent. Fourthly, weigh your reagent using analytical balance. Lastly, dissolve the reagent in the solvent using volumetric flask. Let's move on to dilution. Dilution is a process of reducing the concentration of a solute in a solution, usually by adding more solvent. We prepare a standard solution through the process of dilution. First, a specific volume of concentrated hydrochloric acid is carefully measured using a pipette. Next, the acid is transferred into a volumetric flask. Distilled water is then added gradually to the flask, diluting the acid to the desired concentration. Finally, the solution is mixed thoroughly to ensure uniformity. This diluted solution is now ready to be used for chemical analysis. A dilute solution, which has a lower concentration, can be prepared from a more concentrated solution. To do this, a known volume of the concentrated solution is measured and transferred into a new flask. Distilled water is then added until the total volume reaches the required amount. This process follows the dilution equation, M1V1 equals M2V2, where M1 and V1 are the concentration and volume of the stock solution, and M2 and V2 are those of the dilute solution. Guess the answer. You have 100 milliliters of a 2.0 m HCl solution. How much water should you add to make a 1.0 m solution? Using the dilution formula, we find the final volume should be 200 milliliters. That means you need to add 100 milliliters of water to reach your target concentration. Did you get the answer right? Drop a comment. Chemical stoichiometry. Stoichiometry tells us the relationship between reactants and products in a reaction. It all starts with mass. First, divide the mass by the molar mass to get moles. Then, use the stoichiometric ratio from the balanced equation to find how much of another substance is involved. Finally, multiply by molar mass to convert back to grams.